another bunch of problems, very basic problems on projectile motion. And this sheet titled Projectiles, a few more. So there is this particle launched, let's say, from a point O, and its velocity makes an angle 60 degrees with the horizontal. Root 3 seconds later, if this was t equal to 0, this instant would be t equal to root 3. Root 3 seconds later, the velocity vector of the particle makes an angle 30 degrees with the horizontal. I want to find the horizontal component of the velocity during the motion, right? Now, at this instant, what's the horizontal component? U cos 60 degrees means u by 2. What's the vertical component? U sin 60 degrees means u root 3 by 2, right? And root 3 seconds later, what happens to its horizontal velocity? That remains u by 2. Horizontal velocity remains u by 2, and its vertical velocity root 3 seconds later becomes u root 3 by 2 minus gt. That means 10 into root 3. G is 10 into root 3. That happens to be the vertical component of velocity root 3 seconds later. Yes or no? Right? Now the resultant of these two components is the net velocity that makes an angle 30 degrees with the horizontal, which means this is how it is. This is the velocity diagram. This is the net velocity that makes an angle 30 degrees, and this is u by 2, and this is u root 3 by 2 minus 10 root 3, right? Very clearly, tan 30 degrees would be this length by this length, right? So tan 30 degrees would be u root 3 by 2 minus 10 root 3 divided by u by 2. And this gives us an opportunity to solve for u, because tan 30 degrees is 1 by root 3. Right? And then we cross multiply, we get u by 2 equals 3u by 2 minus 30. U then is 30 meters per second. U then is 30 meters per second. Right? We need horizontal component of velocity, horizontal component which is u by 2, which is then 15 meters per second. Horizontal component of the velocity is u by 2, which is 15 meters per second. Yes or no? I hope all of you got this right independently also. Right? 2 points on its trajectory, and these P and Q are at the same height above the horizontal. These P and Q are at the same height above the horizontal. Half the maximum height in this case, it's given. H is half the maximum height. Now, I want to find the average velocity from P to Q of the particle. I want to find the average velocity from P to Q of the particle. Of course, it's a case of constant acceleration, g downwards. Let me just tell you conceptually. When the particle goes from P to Q, what is its displacement? PQ, which is purely horizontal. Its displacement is purely horizontal. When the particle goes from P to Q, since P and Q are at the same vertical, same horizontal level, at the same height h, when the particle goes from P to Q, its displacement is horizontal. Yes or no? Its displacement is purely, PQ is parallel to the horizontal, right? Is horizontal. That means its average velocity must also be parallel to PQ. What's the velocity parallel to PQ that remains the same? Is u cos theta, v cos theta, isn't it? The velocity that remains parallel to PQ all the time is v cos theta. So should that not be the average velocity? V cos theta. Okay, let me first do it in a little more complicated manner. Then I'll come to this simple method and you will understand the importance of it then. All right. Hey, V1, it's a case of constant acceleration. So average velocity in constant acceleration in an interval is what? V1 plus V2 by 2. V1 plus V2 by 2. Yes or no? Resultant of is half of V1 plus V2 in case of constant acceleration. I've told you, not in all cases, but in constant acceleration, the average velocity can also be obtained using velocity at the beginning of the interval plus velocity at the end of the interval by 2. But that's not the definition of average velocity. Definition of average velocity is total displacement by total time. Now, P and Q are at the same level. So would you not want to believe at P, if this is the velocity, one, the magnitude of the velocities must be the same at P and Q. Both must be, say, V naught. At P and at Q, their velocity magnitudes must be the same and must be, say, V naught. Right? And the angles that this V naught makes with the horizontal from symmetry must be the same. If this angle is alpha, this must also be alpha from symmetry considerations for points at the same level. All this is not required though. So the initial velocity vector is what? V naught cos alpha I cap plus this vector. This is my x direction and this is my y direction. Plus V naught sine alpha j cap, that's the initial velocity vector. Velocity vector at P. The velocity vector at Q, this is the velocity vector V2, which is the velocity vector at Q, is going to be what? V naught cos alpha I cap minus V naught sine alpha j cap. Yes or no? No? If you add the 2 and divide by 2, what do you get? V naught cos alpha, which is the same as V cos theta, horizontal component of the velocity, which is the same as V cos theta because the horizontal component is not changing with time. Is V cos theta? Yes or no? Or, simply speaking, average velocity in an interval would be total displacement PQ divided by total time T. Right? So if I go from P to Q, would you not want to believe that PQ is caused by what? PQ is caused by U cos theta, right? U cos theta remains the same, acting for T seconds. PQ is caused by what? U cos theta acting for T seconds, and average velocity is what? Total displacement PQ by total time T. Total displacement PQ by total time T, which is U cos theta. This is all that was required. That was not required. Got me? Which part? Both? Okay. See, when the particle goes from P to Q, what's the displacement? PQ. What's the time taken? T. But realize that when the particle goes from P to Q, the horizontal component of velocity remains U cos theta. So PQ is cos, and the time taken from P to Q is T seconds. So PQ, displacement in this direction, is caused by velocity U cos theta acting for T seconds. So PQ must be U cos theta into T. What is the average velocity from P to Q? Total displacement PQ by total time taken T. PQ by T, which is U cos theta. So PQ by T, which is U cos theta, that's the average velocity from P to Q. Evaluate that yourself. That was not required. This is lot better, right? Didn't understand? Horizontally with a velocity velocity of 18 meters per second. It hits the ground at the point P, making an angle 45 degrees with the horizontal. There is a particle which is launched from the top of a tower with a velocity 18 meters per second horizontally, right? And it hits the ground at a point P, making an angle 45 degrees with the horizontal. I want to find the velocity at the point P, speed at the point P. Now, hey, the horizontal velocity will remain 18 meters per second at all times. That means, look at this velocity diagram. This will be, this is the net velocity vector, say V at P. Right? And the horizontal velocity will remain 18 meters per second. The horizontal velocity will remain 18 meters per second. This is 45 degrees. Now, if this is 18 meters per second, then the net speed would be what? V sec 45 degrees? 18 sec 45 degrees would be V, isn't it? V would be 18 sec 45 degrees. How about it? V is 18 sec 45 degrees, which is 18 root 2 meters per second. I hope all of you got this right, all by yourself, isn't it? Easy, no? So there is this particle launched with a velocity u, making an angle theta with the horizontal. And there are these two poles of equal height. And the particle just grazes past the top of the two poles, just grazes past the top of the two poles. One at an instant of time 1 second, the second one at an instant of time 3 seconds, right? I want to find the maximum height attained by the projectile. I want to find the maximum height attained by the projectile. Hey, simple. If this is t equal to 1, this is t equal to 3, then the top is reached at t equal to 2 seconds. Yes or no? The top would be reached at t equal to 2 seconds. That means the total time of flight must be 4 seconds. The total time of flight must be 4 seconds, 2 seconds and then 2 seconds, 4 seconds. But the total time of flight is what? 2 times the initial vertical velocity by g. 2 times the initial vertical velocity by g is the total time of flight, right? 4 seconds. That gives me uy equal to 20 meters per second. And h max therefore would be uy squared by 2g, uy squared by 2g, which is 400 by 20 meters. That makes it 20 meters. Yes or no? I hope all of you got it right, right? So there is a particle launched with a velocity u, making an angle 60 degrees with the horizontal. And 30 meters above the ground, it strikes the surface at an angle 30 degrees with the horizontal. What is it that I need to find? U is what I need to find. U is what I need to find. Now, very clearly between points O and P, I can apply conservation of energy, right? It has only kinetic energy here, half mu square, right? At this point, its kinetic energy is half v squared, and in addition, it has potential energy mgh. Can I say this? Conservation of energy? That gives me v squared equal to u squared minus 2gh. Multiplying, dividing by m, cancelling half, etc. This is what I get, cancelling m, right? Where h is 30 meters, so 600, so this is u squared minus 600, that's v squared, right? Now, no matter what, the horizontal components will remain the same, right? Now, what's the horizontal component here? U cos 60 degrees. What's the horizontal component here? V cos 30 degrees. That means u must be v root 3. Using these two equations, you can solve for v. You can write as v as V as u by root 3 and solve for V. How much is it? 30 meters? U is 30 meters per second when you solve for this. These two equations you can solve, obtain U as 30 meters per second. Did this? So in the next problem, what's given is, for a given u, if I vary theta, this is how range varies. This is how range varies. If for a given u, if I keep varying theta, this is how range varies. And the maximum range is 250. Hey, what's the result for range for any given theta? U squared sine 2 theta by g. Right? And what is R max? Sine 2 theta will be 1. That means that's u squared by g. And that's given to be 250 meters. That's given to be 250 meters. So I get u squared equal to 2500 or u equal to 50 meters per second. U is 50 meters per second. Also, what's given is, it's launched at an angle theta, the particle is launched at an angle theta, such that the time of flight, which is given by 2u sine theta by g, is root 3 times the maximum time of flight. Hey, how do you get the maximum time of flight? When sine theta is 1, you'll get the maximum time of flight, isn't it? So maximum time of flight would be 2u by g. 2u by g is the maximum time of flight, and it's given that the given time of flight is root 3 by 2 times the maximum time of flight. The given time of flight, 2u sine theta by g, it's launched at an angle theta, whereby its time of flight is root 3 by 2 times the maximum time of flight. That's given. That's given in the problem. So then, very clearly 2u by g will get cancelled from both sides. That gives me sine theta equal to root 3 by 2, or theta equal to 60 degrees. Theta equal to 60 degrees. Now, what is it that I need to find? The least possible velocity of the particle during the journey. Hey, in a projectile motion, if a particle is launched with a velocity u at an angle theta, then the least speed is at the highest point, which is only u cos theta. At all other points, there is a vertical component of the velocity. So the least speed the particle attains is at the highest point. And u cos theta in this case is going to be 50 into cos 60 degrees. That means 25 meters per second is the least speed of the particle. Yes or no? That's the least speed of the particle. So there are two projectiles A and B launched from the same horizontal level. One with a velocity 2u naught making an angle 60 degrees as shown. The other one with a velocity u naught making an angle 60 degrees as shown. Right? I've of course told you in the past that if you look at one projectile from another, then the path is going to be a straight line. Why? Because their relative acceleration is 0. So their relative velocity will be constant. Right? Whatever initially you witness as the relative velocity of A with respect to B, that will remain the relative velocity at all times. Why? Because relative acceleration is 0. Right? Now, treat B as an observer, A as the observed. So, first of all, I can resolve the velocity of A as 2u cos 60 degrees, which is u naught, and 2u naught sine 60 degrees, which is u naught root 3. That's the velocity components of A along the x and the y directions. Right? For B, it's u naught cos 60 degrees and u naught root 3 by 2. Yes or no? Resolving their velocities along the x and the y directions. Let me convert this situation into an equivalent situation where B is treated as an observer and A as the observed. Right? Where B is treated as an observer and A as the observed. So this situation is like equivalent to A, as if I'm fixing B, B is my observer, then I would have to revise the velocity of A. In this direction, velocity of A would be u naught minus u naught by 2. That means 3 u naught by 2. Relative velocity of A with respect to B in this direction would be u naught plus u naught by 2, isn't it? No. Velocity of A with respect to B along the x direction would be what? Velocity of A along the x direction minus velocity of B along the x direction, isn't it? Their relative velocity along the x direction would be velocity of A along the x direction minus velocity of B along the x direction, right? What's the velocity of A along the x direction? U naught. What's the velocity of B along the x direction? Minus u naught by 2. Minus u naught by 2 because it's in the opposite direction. So minus u naught by 2. So their relative velocity along the x direction is 3 u naught by 2. Right? So velocity of A along the x direction is 3 u naught by 2 as seen by B, and velocity of A in the y direction with respect to B, velocity of A with respect to B in the y direction is going to be velocity of A in the y direction minus velocity of B in the y direction. What's velocity of A in the y direction? U naught root 3. What's the velocity of B in the y direction? U naught root 3 by 2. So that makes it u naught root 3 by 2. Yes or no? So velocity of A as seen by B in the y direction is u naught root 3 by 2. That means these are the velocity components of A as reported by B initially, and these will continue to be the velocity components of A as seen by B at all times, right? And realize that consequently the relative velocity of A as seen by B would be like this. Relative velocity of A as seen by B would be the resultant of these two. This would be the net velocity of A as seen by B. This would be the net velocity of A as seen by B. Yes or no? And this will make an angle, say theta, with the horizontal. This will be the net velocity of A as seen by B. That means A will continue to move in this direction with the same speed as reported by B. This would be the trajectory of A as seen by B. This would be the trajectory of A as seen by B at all times, right? And what would tan theta be? Tan theta is going to be this length divided by this length, which is like u naught root 3 by 2 divided by 3u by 2, 3u naught by 2, 3u naught by 2. Yes or no? Which is 1 by root 3. So what is theta? Theta is 30 degrees. That means the path of A as seen by B is a straight line passing through A, which is the origin, making an angle 30 degrees with the horizontal. Yes or no? Got me now? Sure? Huh? So that's one thing. Now, so this angle I know. So B thinks that A is moving along this straight line, right? Very clearly, it's like B is fixed. So the shortest distance between A and B would be this. When A comes to this point, call it A prime. Then the distance between A and B will be the smallest. Then the distance between A and B will be the smallest. Yes or no? Right? And this theta we have obtained is 30 degrees. Right? This then will be the shortest distance. This then will be the shortest distance between A and B, D minimum. Right? And this length is given to be some L, right? So this is L sine 30 degrees. D minimum will be L sine 30 degrees. Yes or no? So D min will be, this length is given to be L sine 30 degrees, which is L by 2 would be the shortest distance between A and